Okay, so another quick video here on how to make or how to calculate mean and standard deviation from a binomial distribution. Okay, so I've already got here a distribution xp of x. Okay, to find the mean, we've talked about this. To do it by hand, I'm going to find x times p of x, and then I'm going to add those up. And at this point right now, I'm not real crazy about doing all of these multiplications. Now, there's some of them I'm not so bad at, right? You should be pretty good with 0 times 0.0016 and 1 times 0.0256 and maybe even 2 times 0.1536. 15 times 2 is 30. 36 times 2 is 72. That's not so bad. I suppose we could even do what? 8192, so 8192. So that multiplication isn't so bad either. But now I got to add them up. I've got to go to my calculator anyway. Okay. So what I can do is I can put them, notice I've already got them in my calculator into L1 and L2. My L1 is the 0, 1, 2, 3, 4. The L2 is 0.0016, 0.0256, and so on. And I want to find the mean and the standard deviation. So actually, let me tell you about what this is, this information here. So I was at the store with my wife, and we've been, wanting to get some smoke detectors, and she's been bugging me, get a really good one, get a really good one. I don't want to spend 20, 25, 30 bucks on a smoke detector that's going to be successful 90 to 95% of the time. So what I decided to do is I found these online. It was awesome. They were like $5 or $6, maybe $8 at the most per. And I said, I'm going to buy these. Of course, he says to me, no, the probability of one going off is 0.8. The probability of success is only 0.8. You don't want to buy one of those. I said, I'm not going to buy one of those. I'm going to buy 4 of those. Well, if they cost $4 or $5 each and I buy 4, I'm still in it for 20 bucks. It's still cheaper. What's the probability that at least one of them will go off? Well, the probability that at least one will go off during a fire will be, 1 minus the probability of 0. The probability of 0 going off is 0.0016. So point was at 99.84. So it's a 99.84% of the chance that this thing's going to go off on fire. That's still better than one of the others, maybe even 2 of the others. Okay, so not a bad deal. But so what we said is, well, wait a minute. If there is a fire, you got 4 of these fire detectors, smoke detectors. What's the probability that more than one of them will go off? Or there's other videos that you can look at. Do the probability of 1 or 2, right? The probability that 2 will go off will be the 0.3072. What about 2 or more? We could add those up and everything, right? I'm sorry, 2 going off would be 0.1536. And what's the probability of 2 or more? What's the probability at least 1? Binomial PDF, binomial CDF, go ahead and watch those videos. This question, though, is, in a fire, how many of the 4 would I expect to go off? What's the expected value? And so remember that the expected value is the same as the mean. Mu is the same as the expected value. Oops, that should have been an E. The expected value of x, which is the sum of the x times p of x values. So what I'm going to need to do is do, 0 times a 0.0016. I need to find all of these values here, but then I'm also going to need to add them up. Okay, I could do that here in the table in the calculator, but the better way to do this, if I'm going to use the calculator, because the next thing I'm going to need to do after finding the mean is I'm also going to need to find the standard deviation. And that's a formula that I've told you that for purposes for right now, you're going to use the calculator anyway, right? So, you ready? Stat, calculate, number 1, the 1 variable statistics. Our data is in L1, and the frequency with which we expect them to occur is in L2. Calculate. So we have a mean of 3.2. The mean is 3.2. Our expected value is 3.2. I would expect with these probabilities that at any time there's a fire, like if we were to have a fire in a house over and over and over again, which I really hope, but hope not. But if we're to say, here's a household with 4 of those detectors, here's another household with 4 of those detectors, here's another household with 4 of those detectors, and we've got all of this going on. If there's a fire in each of those houses with the 4 detectors, how many would we expect to go off? We would expect 3.2 of those smoke detectors to go off. So there's our expected value. Okay, but what about the standard deviation? It's right here, 0.8. Standard deviation is 0.8. Look for other conversation, other times in class, other videos to talk about the meaning of the standard deviation. But here's how I compute the standard deviation. It's right there. Okay. Oh, and then lastly, what about the variance? Well, remember that the variance is the standard deviation squared. So that's going to be 0.8 squared, which is just 0.64. Okay, or 0.64 squared. Okay, not 0.64 squared, 0.8 squared, which is 0.64. So my mean would be 3.2 with a standard deviation of 0.8 and variance of 0.64.